So we've covered using the Maclaurin expansion to approximate a series to a given value of x. What I'm going to do here is I've got a couple of examples for you. I want you to read the examples, pause the video, have a crack at them, then come back and check you're working with what I'm going to show you. So here you go. First thing I want you to do is use the Maclaurin series to firstly write the first four non-zero terms of sine x, and then use that to approximate sine of 0.9 to 5 decimal places. I then want you to use the Maclaurin series to expand sine squared x as far as the x to the power of 4 term, and then use this to approximate sine squared of 0.3 to 3 decimal places. So pause the video and have a ping at them. So the first one, using the Maclaurin series to firstly expand the first four non-zero terms of f of x is sine x. Well, we've covered this previously. This is one of the ones that you should really know relatively well to the first couple of terms. Sine x is equal to x over 1 factorial. Take away x cubed over 3 factorial plus x to the 5 over 5 factorial. Take away x to the 7 over 7 factorial. Second part of the question was I want to use this to approximate sine of 0.9 to 5 decimal places. So in order to do that and calculate sine of 0.9, what I want to do is substitute it into here. So I've got 0.9 over 1 factorial, take away 0.9 cubed over 3 factorial, plus 0.9 to the power of 5 over 5 factorial, take away 0.9 to the power of 7 over 7 factorial. Now this is one of those lovely ones where you can just simply fire that into a calculator and see what you get. And when you do that, what comes up on the screen is 0.783325, and then it continues on and on and on. And I want to go to 5 decimal places, so I'm going to cut it off there, round it off, and I'm going to get 0.78333. So there you go. It's the value of sine of 0.9 to 5 decimal places. And if you plug it into your calculator and just do sine of 0.9 in that and round it off, that's what you should get. Second question was I want to use the Maclaurin series firstly to expand sine squared of x as far as the x to the power of 4 term, and then I want to use this to approximate sine squared of 0.3 to 3 decimal places. So first one, I'm going to expand sine squared x. Now, sine squared x taking derivatives, a little bit complex, so what I want to do is I'm going to take sine squared x and rewrite it as 1 minus cos squared x. Because one thing I can remember is that cos squared x is equal to a half bracket 1 plus cos 2x. And if I substitute that in, I can take derivatives of that. So I can write that sine squared x is equal to 1, and I'm going to just multiply this out as I go. Take away a half cos 2x. Simplify it, gives me a half minus a half cos 2x. So what I need to do now is expand the cos 2x out, plug it back in, and then see what I get. So what we'll do is we'll say f of x is equal to cos 2x and do our steps as far as we need. So f dashed of x gives me negative 2 sine 2x, so there's my x to the power of 1 term. My x to the power of 2 term, f double dashed of x, is going to be the derivative of this. So what I'm going to get is negative 4 cos 2x. And then I'm going to take the third derivative. This will give me my term to the power of 3. So f triple dashed of x. What that's going to equal is 8 sine 2x. And then my x to the 4 term will be given by the final fourth derivative I'm going to take, which is going to be 16 cos 2x. Now for each of these, I substitute in x equal to 0 and see what I get. Well, f of 0 is cos of 0, which is 1. First derivative f dash to 0 is negative 2 sine of 0. Well, that's just 0. Sine 0 is going to be 0. Second derivative f double dash to 0. It's going to be negative 4 times cos 0. So negative 4 times 1. So it's going to be negative 4. Third derivative f triple dash to 0. Again, that's going to give me 0. And then my fourth derivative of 0 is going to be 16. So I now know what the expansion of that should be. I now know that cos 2x should equal 1. Take away 4x squared over 2 factorial plus 16x to the 4 over 4 factorial. And if I want to sort those coefficients, which is a good idea at this stage, I'd have 1 take away 2x squared plus 2/3 x to the power of 4. So that's my expansion for cos 2x. All I do now is I take this and plug it back in here and see what I get. So I then know that that's equal to a half take away a half times 1 minus 2x squared plus 2/3 x to the power of 4. So if I multiply out this bracket, I get a half take away a half, so that disappears. I then get minus a half times minus 2x squared, so I get x squared. I then get minus a half times 2/3 of x to the 4, so I then get minus 1/3 x to the 4. So that there is my expansion of sine squared x to the x to the power of 4 term. Second one, I then wanted to use it to approximate sine squared of 0.3 to 3 decimal places. Well, quite simply plug in 0.3, so I do 0.3 squared, take away 1/3 times 0.3 to the power of 4, stick that in your calculator, and what you end up getting is 0.087 to 3 decimal places. So there you go, that's me got my solution. For these sorts of questions, it's always the same idea. We get our expansion and we plug it in. Be aware of all your trig identities. I had to use it in this one. Be aware of all your ones involving sine squared, cosine squared, sine 2x, cos 2x, and the various other ones that we've covered in the past as well. Use them all to the best of your advantage.